Hello class, this is section 1.2 and in this video we will talk about temperature and specific heat. So temperature is given as U with arguments x and t, x as usual referring to the location on the rod and t referring to time. The SI unit for temperature is Kelvin, degrees Kelvin, but we will sometimes use Celsius instead. One important point is that temperature and energy density are not the same thing, even though they are closely related, and even though sometimes it's useful to think of energy density as temperature. And the reason they aren't the same thing is that different materials take different amounts of energy to increase the temperature. For instance, it's a simple experiment to check that it takes a lot less energy to heat up iron 1 degree Celsius than it takes to heat water 1 degree Celsius. We thus define this C, the specific heat of a material. It is the amount of energy it takes to increase the temperature of 1 kilogram of a material by 1 Celsius or 1 Kelvin. Now please remember that Celsius and Kelvin are really the same scale. The only difference between the Celsius scale and the Kelvin scale is that 0 Celsius is the freezing point of water, whereas for the Kelvin scale, 0 is absolute zero, the coldest anything can get. But otherwise, the gaps between the 2 degrees are the same. C has SI unit, joules per Kelvin per kilogram, so it's the amount of heat it takes to heat up a material 1 degree per unit mass. And also sometimes we write Cx rather than C. Usually we write C because our rod is usually made up of a uniform material. It's either an entirely iron rod or it's an entirely gold rod or an entirely silver rod or what have you. And if the material doesn't change, the specific heat doesn't change. C only depends on material. But sometimes we want to think about a rod that is a composite of several different materials, and in that case the C might change when X changes, so we have to write down Cx rather than C. Notice that C never depends on T, it never depends on time. It doesn't make sense for the material composition of the rod to change with time. If we start with an iron rod, it should remain an iron rod for all time. Let's also introduce ρ, which is density of a material. This is the regular density you learn in physics, which is just the mass per volume, with SI unit kg per meters cubic meter. Again, usually our rod is just made of a single uniform material, so ρ never changes, but sometimes we want to consider the case where ρ changes along the rod, so maybe the left side of the rod is denser than the right side of the rod. But again, ρ never changes with time because it doesn't make sense for the rod to magically become more dense or less dense over time. So now the equation relating energy density and temperature is just given by Ext equals C times ρ times Uxt. And again, if your situation warrants it, you can write C of x and ρ of x rather than C and ρ. So this is how you relate the energy density and temperature. Rather than memorizing this formula, I would suggest just paying attention to what the units are. For instance, the SI unit for energy, if you may recall, this is just going to be joules per meter cubic meter. The unit for the C, the specific heat, is just going to be joules per degrees Kelvin per kilogram, and the unit for ρ is just going to be kilogram per volume, and the unit for Uxt, the temperature, is of course just degrees Kelvin. And you can see that if you cancel out all the units, it all matches up. So that's what I typically do anyway. I mean, you can memorize it, it's a pretty easy formula to memorize, but at least the way that I think about it is that I just think of what the units should be and I try to match them. So anyway, this is how you relate the temperature and energy density.